Anna-Katrina Shedletsky is one of a group of highly educated rising stars working in the electronics manufacturing community. She's a Stanford grad with an impressive track record. She's a founder of Women in STEM mentorship program, and she spent nearly 6 years at Apple working on system design for the Apple Watch series before co-founding her own company, Instrumental, with Samuel Weiss. We'll be talking to Anna about her work at Instrumental after this.
Welcome to Tech Talk with Trevor Galbraith, a video podcast that features industry leaders and experts from the electronics manufacturing community. Recorded at major events around the world and from the studios of Global SMT TV. Now here is your host, Trevor Galbraith.
And welcome, Anna. Lovely to see you.
Great to be here.
Yeah, you've certainly been a busy young lady recently. I saw you at CES and various things you've been doing, so that was very impressive. But let's start out by just mapping out about the company you have, Instrumental. Tell us a little bit about it. I mean, is it a quality and yield improvement set of tools that you're providing for manufacturers, or is it a failure analysis lab? How would you describe it?
Yeah, so Instrumental is a suite of technologies that automates failure analysis. That's what we do.
Okay.
We support failure analysis, but it's technology to support it. So it's a collection of hardware, software, services that collects unit level process and performance data from your manufacturing lines, from SMA, from box build, repair and refurb, and it leverages AI tools to proactively discover issues and root causes for your engineering team. So your engineering team is doing that process, but I came from, as you said up at the top, I grew up as an engineer at Apple, and I was responsible for finding and fixing issues during NPI to be able to prepare a line and product for production. And it's a lot of manual processes, a lot of being in the right place at the right time, and luck is not a strategy. So let's use data and technology so that we're not relying on luck. We're not relying on the ingenuity of a particular engineer to see something or get an insight or an idea. And you can just instead leverage computation, your data, your IP to identify issues that you have proactively, and then automatically solve and automatically identify the root causes of those issues so you can go and make changes on the line to solve those problems.
Right. Makes a lot of sense, and certainly, the further up the line that you can predict the issue, the more money you're going to save,
Absolutely. And the earlier, the shift left in terms of time as well, finding issues in MPI are way cheaper than dealing with issues in the production case.
Right. So do companies typically engage you at the start of the process, or do they, NPI, or do they call you in after something's gone wrong?
We are equal opportunity and do both. I would say we work across the product life cycle. I'll admit that the technology was originally developed for MPI. That is where I grew up as an engineer. That's the bias I brought to the organization, me and Sam both. But I think that's good for our customers because the MPI case is the hardest technologically. The smallest number of units, the smallest sample set or data, the most variation. Often MPI has many configurations, changes happening. And so it essentially enables us to operate in both high volume and low volume, high mix scenarios because we've designed it for MPI from the beginning, even if you're in a high volume or production scenario. In MPI, you have very few units, and each unit really matters. And so getting all the data about those units and being able to make the strength of onesie, twosie failures where you only have one, and you're, as an engineer, you're kind of well, it only happened once. Maybe it's not a real problem. But if you only made 20, your failure rate is really high. And when you go make 100, it could be, you could have 5 failures or more, right? So, and that could continue to be a problem for you. So in MPI, we're helping our customers go fast. It's all about speed and accelerating their MPI process by proactively finding those issues, enabling them to get to product maturity faster. So customers are shortening their MPI schedules by leveraging technology like this. And then in production, it's all about the core operational metrics of production, throughput, margin, yield, those things. They all really tie together. Product quality might be a piece of that. And so we with production customers who either have an ongoing challenge, like we have a fire and we need a fire truck of technology to come in and help solve it, or we work with them in production because they're like grinding it out on continuous improvement, and they need something to help them get past, where they've already ground down, because there's still more opportunity in the Pareto, but the conventional techniques they're working aren't getting down into those bars of the Pareto.
Right. Okay. Well, so let's dive in a little bit into your methodology of doing this, because different manufacturers use different test and inspection equipment. How do you harness that to provide deep, meaningful, and consistent results across the?
Yeah, the data organization is a huge challenge in general for any AI system. And I think what we've done is we've tried to make this something that you can just easily drop into a line. You don't have to go do a bunch of integrations, because the reality is sometimes you have stuff that you want to start working with and sometimes you have nothing. And so it needs to be able to work in either case. So we've built drop-in sensors. That's kind of a hardware element of the product that enable you to start collecting data directly from your line. And then we've built integrations into MES or functional testers. There's lots of different levels we can plug into where data is coming from to ingest the data. And we organize that data by serial number. So I would say Instrumental is focused on the as-built state of individual units on the line, electronic products. And so it's all serialized data. And there you have a digital thread of every serial number for each of the kind of performance testing that you're doing, the results you're getting, as well as imagery from the line, video from the line, if there's certain processes that really matter. So all that data can be ingested. Bill of material, build matrix information, like vendor details, operator details, all of that can be associated by serial number. So we're essentially using standard kind of communication protocols to be able to pull this data, usually from places it's already been aggregated, but also we can get it directly from stations on the line.
Right. And how long does that take to integrate? I mean, when you take on, to get up and running,
Yeah.
That's a lot of work.
It's actually not too bad. I think we've done it in, I don't want to toot our horn that we've like done it in a smart way, but we've tried to do it in a smart way, because I think one of the ways in which, when customers have problems, they need solutions now. Like, it's very expensive to have a challenge in manufacturing, particularly in a production scenario. And so you can't wait 12 weeks or 6 months for something to come up and running. If you work with Instrumental, we've like signed an agreement. We can generally be on your line within a few weeks, like 4 weeks or so, sometimes faster if there's an emergency situation we're like working really hard for. And then it takes 20 minutes to set up an instrumental station. So you're usually getting data within that first day. And most of our customers get value on the first day from the data they're getting. Right. And so like right away, it starts to provide value. We generally have provided significant ROI back to our customers within 90 days of being live on the line. That's our own internal metric, and it's generally something we're hitting with most of our customers. So it sounds like there's a lot of work to integrate all that data, but because we're kind of often dropping in, we're just integrated with ourselves, and then we're plugging into a couple of other locations. Generally, the MES is very easy to plug into, and that integration is usually 2 or 3 days of work that our team will do as part of providing the service to our customers.
Right. Okay. Interesting. So, you recently produced a couple of little snippets from CES, and I thought that was hugely interesting. So, give me your takeaways from CES. What do you think? What did you see that will impact the EMS industry?
Oh, yeah. I think the thing about CES, particularly as it relates to EMS and, electronics engineers, is that it's actually not about what's happening on the marketing floor and like the glitzy, glammy booths. That's like, I guess what everybody thinks of when they think of CES, but it's actually all the meetings that are happening in the suites above the floor. And so, as many EMS providers, they go to meet with customers, they go to sell their services. And I do think that there is there was a lot of conversation happening in those suites and a lot of shopping for new EMSs as people are concerned about potential disruptions in the supply chain, like maybe due to geopolitical reasons, they might need to move their facilities to a different geographic location, or they might want to be thinking about finding partners in different regions, or partners with different capabilities because they're releasing new products on new chipsets that are coming out. So certainly I think if you're talking about in like a broader sense of like what was cool to see on the floor, I think a cheeky way for EMS, humanoids might be an interesting thing to think about, not just because it's like, oh, here's a product to build that could be here faster than we think. There's a lot of hype cycle happening on humanoids right now, but I think that might go faster than we all expect.
Yeah, well, Elon's talking about putting them on his production lines this year.
Exactly. That's the perspective for EMS is like, oh, could there be in the next couple of years opportunities to automate in omni-purpose ways versus multi-purpose or single-purpose ways of automation? So I think there's something there for EMS folks to be thinking about, like how this technology we use. I think at a broader sense, like, you know, AI for everything. And if you haven't thought about it yet, like, you know, many EMS providers are going to become like AI providers from the perspective that they will soon be building many products that are AI enabled. That is going to be the next, like, at least from a consumer electronics wave, is going to be the next wave of devices to deliver AI technologies into our lives in different form factors.
Yeah, absolutely. I agree. And going back to your point on humanoid robotics, I mean, I think that's got great potential in the box build area, which is very labor intensive at the moment.
Yes, absolutely. I think it's going to be very interesting to see what can be done with that technology. It is still early, so but with advances that we're seeing like almost every day coming out of these AI models that are being built by more and more companies around the world. There was recently an article about just all of the companies as well working on humanoids, and it's actually a lot of companies. Like, it's not just, oh, there's like that weird startup over here and Tesla and like, you know, Sony and Panasonic, like the historical ones who've been working on it for a while. I don't know, there's probably 20 or so, like,
at least
brand name companies working on building these technologies. It's going to be very interesting.
Yeah, if you go to Japan, there's a ton more as well. I mean, Japan is essentially the home of robotics, really. There you go.
Yeah.
Anyway, we've got, of course, coming up in about a month's time, IPC APEX down in Anaheim. And we're very excited to have you present a couple of your programs from our show floor booth. In fact, one of them, the first one's going to be on the topic of AI.
Yes.
So maybe what can we expect to see from you on that? Do you know who your lineup's going to be yet?
Yes, we do. Maybe here's the way I would present this. So for folks who don't know me and my particular angle in the manufacturing space, I tend to be like kind of a low BS, no buzzword. Let's actually talk about the real thing because we have real stuff to do. We're practical, pragmatic people. And so I think there's a lot of AI hype. And Instrumental is an AI company, and we've been working on AI for a decade. But like, let's actually cut through the noise and talk about, you know, what is actually happening right now with AI and what success has there been in actual deployments, what is working, what is hype, what is real. And so what we've done is we've kind of collected together a technologist who's on the cutting edge of actually building AI solutions for manufacturing. We have a user stakeholder who has implemented multiple different kinds of technologies under the umbrella of AI. And we have some business perspectives that are kind of representing the broader customer base of what customers are kind of asking for, needing, and then what is the kind of cutting edge of what's available commercially out there. And so I think it's going to be a really interesting conversation to talk about how AI can actually provide business and organizational benefits today quickly with high ROI. And specifically, I think we're going to be taking aim at automated optical inspection and how AI can really have an impact in improving yield. So not just like, I think a lot of people think of inspection, or at least I've heard the very dismal view of inspection, that it's a non-value add process. And but you know what? A process that improves your yield is a very valuable process. And so I think the opportunity for AI is to take something that's traditionally been non-value add, something that hits your yield Pareto, and kind of flipping that on its head and providing an opportunity to actually have that be something that improves your yield and throughput. And we're looking at it from the scope of both surface mount assembly part of the line, as well as in the box build part of the line, where, surface mount has had AOI for a long time. And you'd be hard pressed to find many SMA lines that don't have AOI equipment. But if you ask people if they love their AOI, like most people say no. Like false pass rate is too high. Like it's bad. Like they just they don't love it. But they also all have it. And it's one of the reasons I think we can generally get 99.9, 99.5% yields out of an SMA process. We don't have those yields in box build. And we also don't have AOI often in box build. So what can we learn from SMA? How can we make SMA better? But then also, what can we then take into box build and do the same thing down there that has happened, over the last 2 decades in SMA? So I think it's going to be a really interesting conversation about a very practical application of AI.
Yeah, I mean, there are some machines now coming out for box build, which are just basically looking at the boxes themselves, making sure the screws are in correctly, there's no cracks and that kind of thing. But that is starting to appear in the box build area. But the interesting point about I've heard some of the MES guys saying that, why do we have inspection at all? If we're doing the process correctly, we shouldn't need it. But I think that's a bit sort of pie in the sky, quite frankly. I mean,
even in a fully automated process, there will be changes in what you put in. Like you get a different reel and the parts are slightly different. Or as you were saying, you were saying in our prep, like temperatures are a little different, pressures, like something's different. You have a different person, on the machine doing something, right? So you cannot control every variable. And so by default, we need to build processes that are robust to change and that can sense when change is happening and be proactive about like automatically essentially self-healing from those changes. Right. And so that's ultimately the vision of Instrumental, is like software should be able to adapt in real time to a range of inputs and produce an optimal product unit based on that range of inputs. And I think there's a huge opportunity to build self-optimizing, self-healing lines based on leveraging all of the data and digital exhaust coming from all the equipment and machines and processes in manufacturing.
There is, but you've got to still have your inspection equipment because they're your eyes and ears on the line, basically. And if you don't have,
and I think like making that part of a positive value, like thinking that the inspection equipment is actually helping increase your revenue. Like, and that bit flip is part of the discussion that we'll be talking about.
That's great. Okay, so let's look at the other panel that you're going to be doing, which is going to be a fireside chat. So who are you going to be roasting?
Yeah, so pretty interesting. There's we have a couple of folks that we're going to be talking to. One of them that I'll highlight is someone who essentially has spent a lot of time integrating to all of the equipment in the surface mount assembly part of the line and leveraging that to essentially create intelligent actions against data against your process. So if a machine is starting to go down or there's a yield related issue in your SMA process, essentially proactively identifying like, oh, it's machine 5, nozzle 3, like all of that stuff, and sending you those alerts. And so that is really based on a lot of data coming off of all of those machines that they've spent many years integrating to all of that equipment so they can pull that data off. And we're going to be talking about specifically, I think, an uncomfortable topic between both the design brand side and a factory EMS side. And that's the topic of transparency of data. And I think there's a lot of discomfort where factories don't really want to share all their data because they don't want to show their dirty laundry. Customers want more transparency and want more data, but they also kind of want their factories to handle it sometimes and not have to be like a laboring oar on the data. So there's a lot of like complexity in the discussion of like who owns the data and who gets the data and what kind of access do they have. But in a future where AI systems are running on both sides, like that are then working to accelerate design on the brand side or improve process and reduce downtime and do scheduling and all sorts of important things on the EMS side, it becomes really important that the maximum amount of data that's possible can be fed into those systems. And so we need to talk about the uncomfortable topic of data transparency and why having a more open-minded perspective about sharing all of the data that is produced in the digital exhaust from the manufacturing process benefits both parties to an extent that it overcomes the discomfort of like, oh, I don't want my customer to know that actually like maybe we're not as like solid on this process as we'd like them to think we are, because we'll figure it out, like, and so I think there's going to be some interesting things around like how to really think about the future that's happening here and the opportunity if that data is shared. And we'll have some specific examples of customers who've really kind of taken that leap of faith to share that data and the benefits that have been received by both parties as a result of kind of being more transparent with the sharing of that data. But we'll also talk about like what it means to share data, like what data are we talking about, why is that valuable, how you could actually kind of go down a process of doing that and get those real business benefits.
Yeah, and I think if you look at the Scope 3 from the sustainability regulations coming in, they're looking for you to be able to have full transparency with your partners, with your suppliers down through the supply chain. And that makes a lot of sense for sure. But I totally get it that, sometimes the more data you give people, the more they hit you over the head with it. So it's a fine line. But for sure, I think we're going to have
there's pros and cons, and we'll be talking about both. But I think that it's worth having the conversation to be talking about data transparency because frankly, if both sides have AIs that are working to their benefit organizationally, whatever their priorities are, then they both need access to that data to really get those benefits. And for the EMS side, like they get the benefits of their data, but also downstream information about performance that they might not have access to is just as important for helping set limits and understand what defects really matter. Versus the brand side, they're looking at feeding in all this information for other purposes to get their MPI faster, to improve their profit margins, et cetera. And that benefits for both parties. A more profitable customer also means more business for the EMS. So there's like virtuous loops when everybody starts playing nicely together and is a little bit more less adversarial than maybe the contract suggests they should be.
Absolutely. Well, I think that's going to be a fascinating debate. And anybody who wants to tune into both of these events, so first of all, I must tell you that they're going to be broadcast live from APEX. So make sure and take a note of the time, 12:45 Pacific Standard Time on Wednesday, March 19th. That's for the AI for Real panel, followed by the Fireside Chat, which is at 1:30. So that is both of these events. Anna, I want to thank you immensely for coming in today and telling us about it. We are hugely excited to see you at APEX, as I'm sure a number of people will be. And I think you're doing amazing things with instrumentals. So thank you for coming in.
Yeah, really excited to see you there in person.
Yeah, you see me in real. Okay, thank you very much. We'll see you later.